basics of mill machinery. The machinery and systems in modern mills require power sources such as electricity and compressed air, as well as electronics, sensors and digitized data to allow automated processes. In this chapter, you will learn basic information about power sources and transmission, compressed air, sensors, control systems, and automation. Power. The primary source of power in a flour mill is electricity. Mills also use other power sources such as compressed air to drive devices such as solenoids and pistons. For ancillary applications, some mills may use gas and steam. Electricity is used to power motors and control systems. When maintenance is being undertaken on electrical machinery, it should be isolated from the power source or the power locked in the off position. This procedure prevents anyone from turning it on and causing injury during maintenance. Mechanical maintenance can be carried out only after a work permit has been issued, and only a trained electrician should perform electrical maintenance. Motors are linked to motor control centres that control starting and protection. These centres should never be opened by anybody other than a trained electrician. Power can be transmitted via couplings, chains, gears, or belts. The rotational speed from the motor to the driven pulley can be changed if they are connected across different size pulleys. For example, the motor driving a roller mill may run at a different speed to the rolls themselves due to the different size pulleys connecting them. Motor speed itself can also be controlled electronically via variable frequency drives or frequency inverters. All pulleys, chains and gears should be properly lubricated and maintained as required, along with all bearings and other moving machine parts. It is more efficient to carry out preventative maintenance on equipment, rather than allowing it to break down at an unplanned time, resulting in operational problems. Belts, chains and gears and other dangerous moving machine parts should also be guarded as they easily crush flesh. Never put your hand near these unless the machine is locked out and you are authorized to do so. Compressed air. Compressed air machinery is often safer, simpler and more robust than electrically powered machinery. Many machine components in a mill are powered by compressed air rather than electricity. Examples are pneumatic cylinders in roller mills, filter cleaning systems in dust collectors and air hoses. Compressed air systems consist of compressors, piping, dryers, reservoir tanks, filters, regulators, lubricators, and solenoid valves. Compressors significantly increase the air pressure in a reservoir tank to about 6 times the atmospheric pressure. Compressors should be serviced at least annually. Compressing the air also concentrates the water vapor in the airstream. Depending on the relative humidity and pressure, this moisture can condense, resulting in rust, accumulation of debris in the air circulation system, and coalesce with other impurities that can cause damage to the process. Compressed air passes through a central dryer to extract some of this water before entering the plant. Dryers should be regularly drained. In humid climates, controlling moisture levels in the compressed air system is particularly important. In the plant, the air is piped to the various machines, where filters are fitted to each machine's inlet. This filter removes dust or other air contaminants. Lubricators may inject oil. Lubricators should be regularly topped up with oil or replaced. Following the filter, there is a regulator to reduce the air pressure down to the optimum for each application. A solenoid often controls the entry of air into each actual machine component. A solenoid is an electrically powered valve that switches the air between different channels in that machine part. The solenoid acts as a gate that redirects the compressed air to different parts of the component. For example, a solenoid might be used to switch a pneumatic cylinder between the open and closed positions by switching the air between different sections of the cylinder. Compressed air can be dangerous and should only be handled by trained operators. It is dangerous to aim compressed air at a person, including yourself. If directed at a person, compressed air can cause injury and even death. Sensors. Many types of sensors are used to measure what is happening in a mill. Some examples of typical sensors in a mill include sensors that measure the temperature of grinding rolls, sensors that detect the level of wheat in a bin, sensors that measure the moisture content of wheat, and weighing equipment used to monitor the throughput of wheat and flour in the mill. Sensors only give accurate readings if calibrated. The correct method and frequency for calibrating a sensor will depend on the sensor type. A flour mill should have a calibration schedule and procedure for all sensors as part of its routine maintenance and production plan. Control systems. Control systems might be hardwired, such as with relays, or they might be programmable like very small computers, such as with programmable logic controllers or PLCs. For example, a packing machine can be reprogrammed as needed to change the weight of flour added to a bag. Never attempt to reprogram a machine without first obtaining permission from operators who understand the machine and the implications of any changes. A mill should have a change tracking system in place to approve and document all changes. Automation. Electronics and sensors enable the automated control of processes. For example, a mill startup process needs to happen in a specific and sequential order. Sometimes there must be a time delay between one machine and the next being turned on. The same is true of the shutdown process. These processes incorporate timers and delays, either hardwired or using PLCs and sensors. Most mills have a suspend option that is a partial shutdown for when temporary issues such as chokes occur. The control systems mentioned so far can be managed with digitized data, allowing them to be integrated with digitized mill management systems. Data from sensors, electronic machine systems, and human operators can be inputted into digitized mill management systems. These systems can manage stocks, mill parts, mill settings, flour quality, and a range of other operations within the mill. This chapter has covered the basics of mill machinery, including power sources, compressed air, sensors, control systems, and automation. The quiz that follows